you to Yu Kui for the invitation to talk about my forthcoming book, An Artificial History of Natural Intelligence. And thanks to John Rue as well for organizing and for help with getting everything together. So I'll begin by explaining the title through a couple of epigraphs from Francis Bacon. The first one is his division of natural history, which included both nature free, proceeding in her ordinary course, and also obstructed by some stubborn and less common matters, as in the production of monsters, but also, and this is what's important, bound and wrought upon by human means for the production of things artificial. And that was particularly important for Bacon, because he also noted that not much can be achieved by our naked hands or by the unaided intellect. Tasks are carried through by tools and helps, and the intellect needs them as much as the hand does. And just as the hand's tools either give motion or guide it, so the mind's tools either point the intellect in the direction it should go or offer warnings. So my artificial history of natural intelligence will play on this duality that Bacon gives us. And we can start with the fact that there is a very important and very disturbing blurring of the artificial and the natural in contemporary thinking about the mind and the brain. We have the brain understood here as essentially the equivalent of an artificial neural network system, dominated by paradigms from machine learning and deep learning. This is interesting because what's happening is, in fact, the artificial neural networks of artificial intelligence are being used to explain the operations of the brain as an actual natural organ. So not only is the brain understood as a kind of computational system, but we also have this reversal, which is the computer being understood as a kind of brain, which is to say, through neuromorphic chip design, we have the neural network system of the brain being imposed upon the computing architecture itself. Intel has also developed a neurosynaptic chip, as IBM has here. So this has led to a long, or is part of a long history of thinking about the computer and the brain, which has led to cognitive science essentially admitting that the only way to understand the mind scientifically is to treat it as a kind of a machine, as an automaton. As Steven Pinker, the person that the humanities professors love to hate, argues that beliefs are just a kind of information, thinking is a kind of computation, and emotions, motives, and desires are a kind of feedback mechanism. So this goes back actually to the origins of computing and artificial intelligence in the 1950s. If we look at the very famous proposal for a summer research project on artificial intelligence submitted by John McCarthy and his colleagues, we can see coming out of Turing's work on artificial intelligence in 1950, this idea that the study is to proceed on the basis of the conjecture that every aspect of learning, and that's a key word there, every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine could be made to simulate it. So this was something that was taken seriously by both those in artificial intelligence, for example, Newell and Simon in their work on simulating human thinking, where we can see that there is a perfect structural analogy between computational processes and psychological processes. So in this period, the brain was obviously the key seat of this problem of how to think about the mind as a kind of machine. And as Shannon and McKay noted in their preface to Automata Studies, among the most challenging scientific questions of our time is this question: how does the brain function? And what the authors here were interested in was the fact that every period understands the brain in terms of the characteristics of machines that were then in use. So we could go back all the way to Descartes, which they do in this particular text, to see that for Descartes, the nervous system could be understood with analogy to the hydraulic machines of the 17th century. As Descartes noted, indeed, one may compare the nerves of the machine I am describing with the pipes in the works of these fountains, its animal spirits with the water that drives them, the heart with the source of the water, and the cavities of the brain with the storage tanks. So this basically inaugurates a whole series of thinking about the body as a machine and the brain as a particular kind of machine, an information machine. And we actually find in this period machines that begin to at least give a glimmer of the idea of what we might call artificial intelligence, namely the automatic calculators of first Blaise Pascal, the Pascaline, in the 17th century, and later in the same century, Leibniz's automatic calculator. And this is just to say that throughout the early modern period, despite resistances to mechanism and materialization of thinking, there was a kind of undercurrent of automaticity in this period. As Hume explained, reason is nothing but a wonderful and intelligible instinct in our souls, which carries us along a certain train of ideas and endows them with certain qualities according to their particular situations and relations. And this was, in fact, assimilated to the animal spirits in the brain. Likewise, David Hartley in Observations on Man from 1749 talked about how the body and the mind are really operating in two registers, twin automaticities. One was the automatic physiological organization of the body, and the other was what he called the secondarily automatic function of cultural habit, which was essentially the deformation and reformation of the brain from the outside. We could even put Kant in this particular trajectory. As Adorno wrote, with only some irony, the structure of the Critique of Pure Reason should be thought of in terms of various materials falling into a machine where they are then processed, and that what then emerges as a result of this processing is my knowledge. What we can see then coming out of the period of Kant was in fact the invention of machines that were, at least in part, meant to imitate certain kinds of cognitive functions. We have the famous first computational machine, automatic machine, that builds on the work of both Pascal and Leibniz, which was Charles Babbage's difference engine, which he later expanded into a much more ambitious general purpose computer, the analytical engine from 1840. We also saw in the 19th century both the formalization of logic and at the same time the mechanization of logic itself through instruments such as William Jevons's logic piano from later in the century, to the extraordinary work of Charles Peirce, who had the insight that logical gates could be simulated through electrical circuits. And this allowed for a certain new design of a logic piano that would be run through electrical circuits rather than through mechanical cogs and wheels. So this dual trajectory of both thinking about the mind and the machine of the brain as a kind of automaton, and also building automata that were capable of what we could call cognitive performances, would lead to this debate in the 19th century, which is, are we really automata? Here, William James responding to Thomas Huxley's infamous lecture that we are just conscious automata. Peirce himself, who was very interested in logic machines, would say, what is really the difference between a human being regarded as a machine which turns out a written sentence expressing a conclusion, the man-machine having been fed with a written statement of fact as premise? Why is this any different than what a machine might go through? It has no essential relation, cognition that is, to the circumstance that the machine happens to work by geared wheels, while a man happens to work by an ill-understood arrangement of brain cells. So we would think that this is, in fact, giving us a historical moment where this analogy could even be more tightly made between the machine and the mind. However, Peirce did not believe that logic exhausted all of human cognition. In fact, he said every reasoning machine is destitute of all originality, of all initiative, and that was extremely important. In fact, what was really interesting for Peirce is that the human mind is not so much a machine, but depends on exteriorizations of its own function in order to operate. He says, in my opinion, it is much more true that the thoughts of a living writer are in any printed copy of his book than they are in his brain. Getting away from this idea that the brain is a kind of machinery of thought, we could actually say that thinking is distributed across the tools that human beings use to do the work that we call cognition. He mentions in another text, if he had filched my inkstand, the very ideas would not come to me. The inkstand and the brain lobe have the same general relation to the functions of the mind. And here he's saying, if we had a damaged brain, it would be essentially the same thing as if we would have our tools taken away from us. Thinking would no longer function in the same way. So in the 19th century, we have this other idea then, which is that the brain is not so much a machine of thought, but a particular kind of organ that uses machines to think. As Cap, in his very influential philosophy of technology, argues, in the hand, the external brain, tools establish culture. So the human is understood as a cultural animal that uses tools to establish certain new forms of performance and new kinds of behavior. Bergson would pick this up in his massively influential Creative Evolution of 1911. As regards human intelligence, it has not been sufficiently noted that mechanical invention has been from the first its essential feature, that even today our social life gravitates around the manufacture and use of artificial instruments. The biologist Alfred Lotka, writing in the interwar period, has made a very strong argument that essentially human beings are defined as a species that use tools and technologies to supplement their natural organs. This ushering in of the era of the man-made adjuncts to his natural body has given not only a new direction to the process of evolution, but has speeded up its progress to an extent without the remotest parallel in the history of our globe. The most singular feature of the artificial extensions of our natural body is that they are shared in common by a number of individuals. Again, this idea that through technology we share a certain kind of thinking, a certain mode of thought that is dependent on tools and dependent, therefore, on sharing technologies across the generations. This is what was most important for Lotka, the thought-transmitting propensity, he said, of the human species. So humans think through tools, and through tools are able to transmit their thinking to other human beings. What he ended up writing in his iconic article on evolution from 1945 was that human beings are defined as an exception in the state of nature, precisely because of the fact that they undergo what he calls exosomatic evolution, evolution outside of the body. So that human performance, human thinking, human cognition at its core was dependent on tools and technologies, and these technologies would evolve rapidly, far beyond the pace that biological evolution was organized. So we can follow this idea in this period, which is to say, thinking does not take place, strictly speaking, inside the brain or the head, and therefore cannot be automated as if it was a machine. As Wittgenstein noted in his reflections from the 1930s, one of the most dangerous ideas for a philosopher is, oddly enough, that we think with our heads or in our heads. The idea of thinking as a process in the head in a completely enclosed space gives him something occult. So what he wanted to say is, and he questioned this critically, is thinking a specific organic process of the mind, so to speak, as if we're chewing and digesting in the mind. So you can literally imagine artificial digestion, as in this art project from the early 2000s. But what interested Wittgenstein was the fact that thinking did not seem to have that same sort of quality. Can we replace thought by an inorganic process that fulfills the same end? As it were, use a prosthetic apparatus for thinking? How should we have to imagine a prosthetic organ of thought? That was Wittgenstein's question. So the question for us is to say at this moment, what exactly is the role of the computer as a new form of thinking and as a new form of exteriorization, this exosomatic process that Lotka imagined? What status does it have within the domain of human thought itself, as opposed to the traditional thinking around artificial intelligence, that the computer could be understood as a giant brain that is essentially thinking like a human being? We can step back and think a little bit more about this alternate trajectory. So what is the machine of the brain if we want to go beyond this particular metaphor of the computer? And one of the reasons to go beyond this metaphor of the computer is precisely its dehumanizing potential. As Horkheimer wrote, advance in technical facilities for enlightenment is accompanied by a process of dehumanization. The more ideas have become automatic, instrumentalized, the less does anybody see in them thoughts with the meaning of their own. They are considered things, machines. So this is the way we might normally approach the emergence of the computer, as a kind of automatization of thinking, an automatization, at least on the level of the models of what human cognition is capable of. But looking through this with the lens of Alan Turing's work, I think we can come to a slightly different conclusion. Yes, according to Turing, the machine is something that is completely described by the relation between its possible configurations at consecutive moments. It's an abstraction that cannot change in time. But what Turing wanted to speculate about was, how could we take a machine like the computer and offer it what might be called a cultural education? And for this, he used the word interference. If we now consider interference, we should say that each time interference occurs, the machine is probably changed. So the idea here is that the machine is something that is not static, but is profoundly altered by outside interference. And what was interesting is he made the analogy here between the machine, like the computer, and the human being. We may say that insofar as a man is a machine, he is one that is subject to very much interference. Now, how is this possible? It was possible because for Turing, the brain was not a machine that could be imitated by another machine. It was a kind of open system. As he said, the cortex is an unorganized machine. The cortex of the infant is an unorganized machine which can be organized by suitable interference training. A human cortex would be virtually useless if no attempt was made to organize it. So what Turing was arguing here is that the human mind is predicated on a brain that is open to being formed and deformed by external influence. And we would have to say that would include the influence of technology. So to organize an unorganized machine, we have to interfere with it. But what Turing also noticed is that because the brain is open, it is what we might call a plastic organ. Processes that are learned do not produce 100% certainty of result. If they did, they could not be unlearned. So here, intelligence for Turing, the intelligence that comes with cultural learning, was not something that was imprinted, again, passively on the brain, but the brain was capable of unlearning and therefore doing something unusual or new. And this leads into a very important part of Turing's work, which is his emphasis and his insistence that machines must be capable of error. If a machine is expected to be infallible, it cannot also be intelligent. The machine must be allowed to have contact with human beings in order that it may adapt itself to their standards. So the machine, like the human, is constantly being interfered with from outside, but also constantly bringing to its behavior its own resources within its plastic brain. So as Turing defined it, intelligent behavior presumably consists in a departure from the completely disciplined behavior involved in computation, but a rather slight one which does not give rise to random behavior or to pointless loops, pointless repetitive loops. So for Turing, what makes cognition possible is interference from outside, and in some ways what we might call the automatization of the brain. But at the same time, the brain was always capable of not being automatic, of introducing a certain kind of unpredictability, which was itself the core of intelligent behavior. So if we look to key work from the 1960s in the wake of Turing's analysis of understanding cognition and intelligence, we can say, along with Lotka, André Leroi-Gourhan, the paleoanthropologist, was interested in the way that humans define themselves in nature by exceeding nature through technology. The whole of our evolution, he says, has been oriented toward placing outside ourselves what in the rest of the animal world is achieved inside by species adaptation. And here he drew attention both to the fact of tools, but also this capacity to share knowledge across generations through technology. That was fundamental for Leroi-Gourhan. So with the evolution of tools from the very beginning of the crude stone tools from millions of years ago through the Paleolithic and Neolithic periods, Leroi-Gourhan was arguing that thinking was enabled by this exteriorization of thought. So again, to pose the question of the computer in this period, what exactly should we think of its status, as an imitator or a machine that is simulating human thought, or a particular kind of machine that could be understood alongside any other technology, that is, as an exteriorization of human capacities into inorganic technical artifacts? Well, with Leroi-Gourhan, we could say that his whole idea that the that technology was the origin of human thinking through the evolution of the brain and the liberation of the hand, we would have to say that evolution had now entered a new stage in the 1960s, that of the exteriorization of the brain. And from a strictly technical point of view, the mutation has already been achieved. So here, Leroy-Gourhan was referring to the recent achievements of artificial intelligence. So if other technologies had been exteriorization of human organs, human muscles, and human receptors, and so on, we now have this radical new event, which is the exteriorization of the brain itself. What this meant for André Leroy-Gourhan is that the cerebral cortex, however admirable, is inadequate or lacking, just as our hands and our eyes are inadequate. In other words, they're supplemented by technologies. And the technology in terms of thinking about the brain is electronic analysis methods. And this, for him, would lead to the condition that if we are going to continue to evolve as human beings, we would have to escape this condition of being a living fossil and eventually follow a path other than the neuronic one if it is to continue. So that's the question I want to ask, is what does it mean to think about a neuronic future where artificial intelligence takes over the capacities of the brain and in some ways leaves behind the human brain? What does it mean for thinking about human intelligence? And the argument that I would want to make is that the key relationship is how the human mind is already externalized through technology. And what's special is the particular characteristic of computer technologies themselves, especially since they are so intimately linked with cognition. So one thing to do here is, instead of taking the track of artificial intelligence, which is to say the track of research that tries to imitate human cognition with machines, we could look at the tradition of what's called intelligence amplification, which comes out of the work of Vannevar Bush and someone like J.C.R. Licklider, who are interested in the new possibilities for thought of the new technologies. As Licklider put it in his Man-Computer Symbiosis, what's important here with this new linking is to enable man and computers to cooperate in making decisions and controlling complex situations without inflexible dependence on predetermined programs. So this was a way of introducing that sort of unpredictability, the possibility of fallibility and error, but the possibility of invention, not so much in the human or in the computer, but in the human-computer symbiosis. The resulting partnership, he says, will think as no human brain has ever thought. And of course, it would also think would think as no artificial brain has ever thought. In other words, as any computer has thought. It was the linking between the two that would produce this new form of intelligence. Now, the person that we associate most with intelligence amplification is Douglas Engelbart, who is revered for inventing not only the mouse, but also word processing and graphical user interfaces. But what was interesting about Engelbart's work was precisely this emphasis on the interlinking between the human mind and its technologies. And what he was arguing was that techniques of graphic representation of symbols allow us to develop procedures for recording our thoughts and for more complex concept manipulation than our minds could otherwise accommodate. And he mentioned here the traditional technologies that allow us to do that, whether it's the pen, the desk and the filing cabinet, office duplicating equipment, or telephones. But of course, what's really important for Engelbart in this period was the emergence of the computer. In his landmark study, Augmenting Human Intellect, he emphasized that thinking was dependent on the kind of culture and technology that we have at any particular moment in history. He called this a kind of neo-Whorfian hypothesis, that the language that's used by a culture and the capability for effective intellectual activity are directly affected by the evolution of the means by which individuals control the external manipulation of symbols. So what we had with the computer, here's a depiction of how he sees humans fitting in with artificial processes in a comprehensive behavior of cognition. What he was interested in is that this distributed intelligence, and here he uses that word distributed in this quote, that intelligence is distributed, it's going to take on new characteristics when we use the new computers. it seems reasonable to consider the development of automated external symbol manipulation means as a next stage in the evolution of our intellectual power. So like Lotka with his idea of exosomatic evolution, we can see that with Engelbart, different technical means of symbol manipulation lead to great revolutions sometimes in human thinking itself. So the emergence of writing, the emergence of print, and now with the emergence of automated symbol manipulation and the computer. Human evolution proceeds then exosomatically, as Karl Popper picks up in his work from 1970, and the organs are not the ones that we would typically think of. Organs are tools, weapons, machines, or houses. But what's also important are the kinds of exosomatic entities that allow for increasing of cognitive capacity. So not just the replication of muscular or sensory information, but literally, instead of growing better memories and brains, human beings are capable of growing paper, pens, pencils, typewriters, dictaphones, the printing press, and libraries as ways of extending and amplifying our intelligent capacities. And like Engelbart, Popper pointed to the computer as the new zone of operation. These add to our language new dimensions, these technologies, and the latest development is the growth of computers. Thinking is to a considerable extent controlled by these exosomatic linguistic systems, which is to say that human beings in the post-war period had entered into a new era of intelligence, which is intelligence enabled by the exosomatic organ that is the digital computer. So if we look to the cyberneticist Gregory Bateson, again, he emphasizes the idea of the distribution of cognition across the human mind, the brain, and external technologies and environments. So his famous example of cutting a tree with an axe, he wants to say, is a process that's brought about by the total system, the tree, the eyes, the brain, the muscles, the axe, the stroke, the tree. As he would say, it's this total system that has the characteristics of immanent mind, not simply the brain in the middle of it, but the system as a whole is capable of a new kind of performance of thinking. So what thinks for Bateson is the total system, which is to say, what thinks is going to be the system of humans operating with their symbol manipulators, the new computers. So I'll take a turn now and return back to artificial intelligence, because I want to say that at the very origin of our newest and dominant paradigm in artificial intelligence, namely machine learning and deep learning, at its origin actually alludes to just the questions that I've been raising in this history of thinking about the exosomatic capacity of the mind, and particularly the digital computer. In the famous parallel distributed processing volumes, we have what seems to be a pretty standard, for us anyway, idea of the mind as a kind of artificial neural network. But the authors of a key text, theoretical text in this volume, ask a very unsettling question. If the human information processing system carries out its computations by settling into a solution rather than applying logical operations, why are humans so intelligent? How can we do science, mathematics, logic, etc.? How can we do logic if our basic operations are not logical at all? In other words, where is the capacity for sequential organized thought, which we associate with intelligence, if our brains are simply neural networks that are performing these kinds of systematic calculations of prediction and settling into solutions rather than working through solutions? Well, they argue, they suspect the answer comes from our ability to create artifacts. That is, our ability to create physical representations that we can manipulate in simple ways to get answers to very difficult and abstract problems. So this takes up the question that Leroy-Gourhan raised in his own work, which is that it's the construction of technologies that allows for a certain kind of new thinking that humans are capable of. Not only can we manipulate the physical environment and then process it, we can also learn, they say, to internalize the representations we create, to imagine them and then process these imagined representations just as if they were external. The external environment becomes a key extension to our mind. So here at the origin of thinking about machine learning, we have an admission, a kind of shocking admission, that the key aspects of intelligence would be predicated on this ability to extend out of our minds into artifacts and to re-internalize those artifacts in order to organize thinking in a new way. In other words, organized thinking and intelligent thinking is predicated on the extension of the mind distributed across these different technologies. So Merlin Donald, writing in the 1990s, his famous and influential book, The Origins of the Modern Mind, would make a similar point. Only in what he calls elaborate exographic systems can the products of thinking be frozen in time, held up to scrutiny at some future date, altered and re-entered into storage in a repetitive iterative process of improvement. So again, the question is, what is the role of the computer in this history of the exographic? Well, we can look again to work that was being done in the 1980s and the 1990s around distributed cognition. While mainstream cognitive science looks for cognitive events in the manipulation of symbols, and more recently patterns of activation across arrays of processing units, distributed cognition, according to Edward Hutchins, looks for a broader class of cognitive events and does not expect at all such events to be encompassed by the skin or skull of an individual. This is to undercut any attempt at artificial intelligence that would simply look at the mind or the brain as an individual unit rather than as part of a distributed system. We can draw, in this context, I think, links with Bruno Latour's massively influential work on actor network systems that bring together technologies, human beings, architecture, infrastructure, and so on, into thinking about how intellectual production actually takes place in the real world. As he himself said, thinking about computers in the 1990s, intelligence has undergone changes which are as drastic as the evolution of technology, with so many intellectual technologies being introduced, from pocket calculators to material environments and so on. The very distinction between natural, situated, tacit intelligences and artificial, transferable, disembodied ones has been blurred. And we could argue that, in fact, it's been blurred from the very beginning, as Leroy-Grand argued with the stone tool. So as Hutchins emphasizes, the environments of human thinking are not natural environments. They are artificial through and through, and they develop or evolve over time. Humans create their cognitive powers in part by creating the environments in which they exercise those powers. So again, the point of artificial intelligence would miss this distributive capacity of the human mind. So the extended mind becomes a kind of trope in the wake, in particular, of the work of Andy Clark and David Chalmers from 1998. But we can see it even more clearly in Andy Clark's work on cognitive science in our own period, where he again emphasizes that humans, unique in the terrestrial natural order, build and repeatedly rebuild the social, linguistic, and technological worlds that we live in. And why is that? It's because the brain is particularly odd in the human case by being open and plastic to a degree that is not the case with other animals. It is because the brain itself is such a potent organ of unsupervised self-organization that our sociocultural immersions can be as efficacious as they are. So we can see this movement developing in a number of different domains in the 2000s, including what's called cognitive archaeology with the work of Lambros Malafouris. And again, the same point is made, is that the use of technology is not simply a kind of normal way of thinking about using a tool, but the tool itself is a way of thinking. The making of a stone tool is not the product of thinking, it is a way of thinking, so that the mind, through its tools, is capable of doing something out of the ordinary and something that was not possible with what we might call a natural brain. So where to go from here? Philosophically, this problem was first addressed by Bernard Stiegler in his formative work, Techniques in Time, Volume 1 from 1994, where, taking up Leroy-Grand's work, he basically made the equation that anthropogenesis, the origin of the human, is technogenesis, the origin of technology. And for Stigler, it's impossible to separate then technical from biological elements of the human. With the advent of exteriorization, the body of the living individual is no longer only a body, it can only function with its tools. So we have to think about human cognition and life itself through an examination of everything from the skeleton, the nervous system, but also what we could call the technical equipment of the human being. radically put, the human is not that which invents the tool, but we can just as easily say that the tool invents the human. It is in this sense that the what invents the who just as much as it is invented by it. So this is very much a paradoxical origin, but it gives us the insight that Bernard Stiegler wants to give us, which is that there is no distinction between human thinking and thinking artificially, that all human intelligence is artificial intelligence because it's mediated and constructed through the form of technology itself. So the projection of the mind outside itself constitutes the mind through its materialization and spatialization. There is no mind before its externalization into technology. So the fact that the exteriorization of the mind is the condition of its constitution means that the mind cannot be some pure substance that by exteriorizing itself alienates itself through this exteriorization. The exteriorization, in other words, is the moment when the mind comes to be a particularly human mind. And that exteriorization is always at the same time an interiorization of the structure of the tool into the brain itself. So for Stiegler, the tool is always going to be an anticipation of an unnecessary future because it's essentially artificial. It doesn't emerge from biological evolution, but emerges from the invention of the mind itself. Which is to say that the tool is always a novel organization of the inorganic. It's a novel organization, and because it's an organization, it's an ordered sequence of operations, and it also operates then as a kind of form of stored memory. This is all to say that the thinking that is human is not taking place in the brain, but takes place at the interface of the brain and its external technologies. What I'd like to emphasize here is that for Stiegler, anticipation of this unnecessary future is anything but prediction. It's always invention, the invention of a possibility that has not occurred before. And I mention that because machine learning paradigm is predicated precisely on this idea of anticipating the future based on the analysis and processing of past data. For Stiegler, unlike artificial intelligence programs that operate today in machine learning, every individual thought is always going to be a reanimation of the dead thought of another mind in the technical artifact. And because it's a reanimation, it's always going to be what we can call an event that is always unpredictable, because the human individual always exists in the unique conditions of thought that are in a living body that exists in a complex social political organization. So human thinking cannot be understood as the product of the machine organ of the brain, because the brain is always reanimating the thought of other people, whether it's in the form of language itself or whether it's in the form of artificial memory through books and so on, through computers and other kinds of storage mechanisms. Now, it's this status of the event that is so problematic for Stiegler in the contemporary era, and this is what many of the theorists of distributed cognition have not paid attention to. What Stiegler calls the automatic society is, in fact, the effort to understand the contemporary situation as one where calculation is, in fact, destroying what we might call the event of thinking. This is an era in which calculation prevails over every other criteria of decision-making, and where algorithmic and mechanical becoming is concretized and materialized as logical automation and automatism. And this is because of the special character of modern digital infrastructures, according to Stiegler. So if automation makes digitalization possible, but if it is immeasurably increases the power of the mind as rationalization, it can also destroy the mind's knowledge as rationality. And that's the key problem that Stiegler sees in the contemporary era, is the destruction of our knowledge, because rationality is not prediction and control, but the opening up of the unpredictable and the novel. So if intelligence is not prediction, intelligence, and here Stiegler looks back to both Heidegger and to Alfred North Whitehead, we want to say that intelligence or rationality in its genuine form is all about wandering, about error, about bifurcation, about approaching the unpredictable. The problem for Stiegler in the contemporary era is that the digital infrastructure is short-circuiting what we might call the individual as event through the direct manipulation of our nervous systems. All artificial memory, which is all human memory, is integrated via digital infrastructures as well across many different registers, which is to say the goal of the contemporary digital infrastructure is the elimination of all the inconsistencies that produce for the human what is a necessary errancy. By that, I mean through techniques of attention control, or to borrow a set of terms from Habermas, we can say how the digital has infiltrated all the different domains of the human, the public, the private, and even the intimate, not so much to offer us tools for new ways of living, but to actually produce digital traces that can produce themselves machine predictions and greater control of human behavior. Now, what I would like to end with is the fact that Stigler did not believe this to be an inevitable conclusion, but in fact pointed to the capacity of the brain to emerge from these particular forms of automatization in a way that looks back, I think, to Alan Turing. As he said in an interview recently, the brain is an automatic machine. In other words, it's a brain that can become automatic. That's essentially what cultural training is all about. But it's also a machine capable of disautomatizing its own functioning. And that's what we have to point out as the important dimension of thought today. This is, in fact, how he described what is the power, the noetic power of the human mind. It is a power not simply to rationalize, but to disrupt and to disautomatize, that is, to change the rules, which is entirely opposed to the contemporary machine learning paradigm, which is to instantiate the norms that are already there within the system itself. So I'll end with a quote from Gilbert Simondon, which is to say, let's remember that in all of these particular trajectories of automatization and control, the human being is always what he calls a rather dangerous automaton, because it always risks inventing, giving itself new structures. And according to the trajectory that I've tracked here, these new structures and these new inventions are always predicated on the human being as a technical creature. Thank you.